Hey there, how are you?
Alright guys, thank you very much. Thank you for your patience while I figured out where Jade was and it wasn't upstairs. My name is Ben Wu. I'm going to be the chairperson for this event tonight. Enjoy the meal that you're getting at the back. Don't drink too much yet. There's plenty to come. This plenary session is all about the software-defined data center. It's possibly the most fascinating aspect of what we're going through today in the 2010s as we go into the next decade. How do we define our data centers? How is it going to look tomorrow? What are we going to be doing? Will we have a job? Those are the questions that we're actually going to be asking about. We have a couple of presentations to go through before I go and harass the rest of the panel I have in front of me. First panelist with the presentation is Mr. Bob Pierce from Altera Corporation, and he's going to be giving you a presentation on software-defined data centers for the Programming Model Summit. Bob?
Welcome. So I guess I didn't get the memo where the presentation was optional here, so now you're going to have to sit through this. So there's been some things that are going on here that are changing the dynamics of what we think are servers and how it's going to be deployed and what we're doing. And so some of these things that are kind of open source was the Microsoft white paper with Altera, where we actually did a network traffic management system for Tor's cluster, and so this was kind of the beginnings of what we look at as far as how do we actually move data effectively through the server systems. The next thing was from Diane Bryant, who brought up a new dynamics as far as what should we expect from a processing perspective, right? And so she basically went out there and said that, you know, QPI gives you a 2x speed up. Well, it's a 2x speed up of what, right? So QPI is an interesting attribute associated with that. But the thing that she brought up was about FPGAs as a multi-chip module. And so this was kind of an interesting approach, because if you understand QPI and how it actually gets utilized, then you can actually see the benefits associated with that. Then again, at the Intel Developers Forum, she came back out with the CTO of F5, and all of a sudden it was back to Xeons and FPGAs. So now we have a network guy talking about FPGAs associated with virtualization inside of the network. And then basically the HPC wire for FPGAs is this the year of FPGAs? You get the thread here, it's FPGAs. I gotta do something here. But anyway, but it's not just about direct attachment, but it's also about the heterogeneous computing environment that goes on out there. Add one more in there. So what is software-defined data center, right? Well, I mean, I got booklets here. I'm going to read this one, by the way, and so save me a copy of that. So every time I go to a meeting, is we spend the first 5 to 10 minutes talking about what's your definition of a software-defined data center. And so finally, when we get all the naming conventions down and what we think we know about it and all the other stuff is, we realize that we have two different concepts for the same idea. And so I think that this is going to continue. So basically what this is a virtualization of the computation, storage, and networking environments. So from a networking side, I know there's some networking guys here that are going to talk about, you know, software-defined data centers or software-defined networking and all the other things that go along with that. I think that's one attribute that helps in changing the things. The other thing that's changing is the value of data. The value of data is by far the most important thing going on. And that's really where the accelerators are starting to come in. But the thing is we've always done offloads through hypervisors. And so what that does is it really takes down the efficiencies of what the CPUs are good at. In addition to that, is if you actually look at what the CPUs are doing, is you find out that most of the time they're doing management of or formatting of data or filtering of memory technology or filtering of memory data. And this doesn't really suit it very well because it's a very serialized approach to it. As far as the acceleration on data accessing is you want to remove the amount of data that you're moving. Because every time I'm moving data and I'm not doing something with it, it's costing me power, it's costing me money, and it's costing me maintenance, right? So the cost of ownership goes up every time I'm moving data without doing something with it. And then the other thing that you're starting to see is a lot of compression, encryption, and deduplication. So deduplication's been around for a long time, so I'm not going to spend any time there. But when you start looking at encryption and compression, is that this is not only improving the benefits as far as your network is concerned, but it's adding security to your network as it goes through. So now you're starting to see multi-key type security elements where, you know, one cluster can have one set of keys, another one another set of keys, and so on and so forth. And so it's getting much, much more sophisticated. And how do you centralize compression? Right? You have to ask yourself, where do I do that? What's the most effective place to do that? It's not centralized anymore, and if you go to just the top of the rack, which kind of does away with what a software-defined data center is now you would centralize compression up in the switch someplace, right? So where you place things is just as important as to the application of what you're doing in the software-defined side. I'm going to speed up now. Okay. So cluster computing, I'll get into some of these things, but what I really want to do is I'm going to highlight 3 basic points here. So it's going to really be networking, direct attachment, and memory types of things. So if we look at the OS bypass, so you know I read software, I read all these software-defined data center things, and by the way, guys, you guys do great white papers. I read them all the time. I'm actually now at a 12th grade reading level. So after 300 pages a day for the last 6 months, I think I've got it down. But if we just look at what we're doing on the top side of things, is we're just queuing things up. We just keep sending things through here, and we keep dumping more memory into these things, and we're not getting any data for it. So we move data, we store data, we refresh that data, we burn more power, we run the susceptibility of having problems if we're doing a large data set or something else like that by the loss of resources, or CPU resources, or memory resources. And then eventually it gets to the GPU or the offload engine, and then it comes back to the same basic archaic system that we've always had. What we really want to see is what's on the bottom side of this. Is what we want to see is that we put the application out there, it goes into the operating system, or just slightly below the operating system, goes to the accelerator, and then comes back out so that I can actually do something with that. And so now all of a sudden, now I have an efficient capability to do that. But how do I keep doing that if I keep bringing everything up to a top or, you know, yet another hypervisor level? Is you don't get that anymore. So now it has to go into another intermediate format. So what we see is basically this capability of getting data in a natural format or in a natural structure so that it goes to the memory and to the location that it should go to. So if I'm not changing the formats of everything, then I'm basically efficiently moving data through my system. And by doing that is I do that in software because I want to be able to reconfigure this thing easily. Right? I don't want to have to send somebody out there and swap this cable to do this, to do that, and the other things. So one of the other things that's changing as far as what we think about, right, is IBM was kind enough to put this into the open source environment using a CAPI interface. And so what do you want to learn from this is you look at the left-hand side. So this is a legacy PCIe environment. So not only are the servers running out of PCIe ports, but it's already OS aware. So now I'm back up into this virtualized world of hypervisors and multiple OSs and everything else like that. So wherever that software level is, this is where I live today, right? That's very inefficient. If we start moving over to a coherent memory or a direct attach bus, like a CAPI type of interface, or you know, I have to give Intel their thing as well, which is QPI at this point, is now I can stay below the operating system. And so now, if you remember that table of what I'm doing now, is now I can actually send from a coherent memory of DDR3, 4, whatever's out there, through the 4 to 10 memory banks that are out there, I can now have coherency to that accelerator that's sitting out there. So yes, it's not a dense compute environment, but it is an accelerator that has, let's say 128 gigabytes of information, of storage that I have out there. And maybe it has an optical network that goes back into my storage elements so that I can save things periodically without loading up the PCIe environment. But this is what's changing. So you asked me, what's software-defined data center? Well, it depends. Did I do this? Do I do direct attach? Do I not? Do I actually put a network onto this direct attach capability in order to circumvent all the overhead that I've been living with? And isn't that much easier to do as opposed to having to change a switch or change this or some of the other more difficult things? And so this is why we always talk about, well, what's software defined to you? The other thing that's going on is hardware guys are a dying breed. Trust me, I know. And so the thing that's out there is there's an abundance. Well, let's not call it abundance, but there's a lot more software guys out there. And so the thing that we see right now is in the heterogeneous computing environments, is OpenCL is starting to take off. So, I've only been at Altera just under a year now, and basically when I first started, we only had a few OpenCL designs. Now it's kind of like, it's kind of like, can we get something else, right? And so what this has done is it's parallelized the computing environments. And when you parallelize, you get lower power. And when you get lower power, you get more efficient. And now you can have recompiling of a heterogeneous computing environment so that now you can have direct compute capabilities for whatever you're doing at that particular time. Hence, it's very interesting for cloud guys that one minute I'm doing the word search, the other one I'm doing a convolution network environment where I'm looking for pictures, or I'm doing something else like that. So this is where we start to see some of the dense compute kind of things happening out there. Because all the algorithms are changing, because data is money for these people, right? And so this is what we're doing on this side of things. The other thing, and I'm getting close to the end here, is network virtualization. So we're all familiar with the Mellanox NICs and everything else. I mean, they own a fair amount of the market segment out there. But the thing that's happening out there is that if I'm going to transport, and I'm going to virtualize everything, and I'm going to transport native technology or native formats like InfiniBand or something else like that, is I can throw everything over Ethernet. I just have to packetize it and reformat it and send it over again, right? But if I can actually make a NIC that's intelligent, now I can basically reconfigure my network at a NIC level, and I can change where I do my compression, and I can change where I do my encryption, and I can change what I'm transporting. And with that capability, now I truly have a software-defined data center. So, summary. I told you I was going to move fast. So virtualization. So as you can see, it's just not more hypervisors. Hypervisor is a software, and yes, software-defined data center has software in it, but software as a configuration, not as a control element, right? API accessible. Everybody's going to be writing their own APIs to make sure that the system works with their environment. Computational storage and networking. This is where we really have to do, whether we move storage into an intermediate phase or we move it onto a direct attach. But any way we do it is we're still going to have to go to networking, which I'm sure this software storage guys are going to talk about. Software friendly. Software tools have to be easier to use. What's the most difficult thing? I got to go buy a hypervisor. I got to spend 30 people for 2 years in order to write a new hypervisor to work on my system. That's not easy. That's not software defined. That's not even virtualization. It's virtual deployment is what it is. So you really have to figure out ways of doing something different. And so one of the means is through OpenCL, but I think as we move up towards even the more abstract Javas and some of the other things like this will become even more familiar as we go into these software-defined elements. And then acceleration. I hope you can see the direct attach approach, whether it be memory or whether it be accelerators, has huge benefits as far as the direct performance advantages that you can get from all of these processors. And creating super nodes where you can virtualize these elements to work over multiple problems becomes very, very interesting. Dense compute is a secondary capability for larger data sets. And then reconfigurability. Without reconfigurability, software changing of just the same hardware is just software changed hardware. Right? It's not a software-defined data set. So, thank you. I hope you enjoyed it.
Thank you, Bob. That was very thorough, and I appreciate that very much. Gentlemen, ladies, please, if you're standing, I've just done the deal with our next speaker. If you sit down right now, he has 5 slides, and he promises me he'll do it in 3 minutes. Please sit down right now. I'm not joking either. Talking about our next speaker is Balaji Pichakani from Dell. He's Senior Director for Product Management from Dell, talking about open software-defined data centers.
Thank you. I'm going to do Bob's 5 minutes. Okay, so I did promise I should do this in 3 minutes. So let's do the best way to do this is I'm not sure how many of you actually have seen some of the Dell slides. Well, it's all coming up here. It looks nice here. Let's do it this way.
That's 1 minute already.
That's right. Hey, that doesn't count on my time. Okay. So I'm not sure how many of you have seen actually some of Dell's perspective on open data center, software-defined data center. So I kind of lied. I probably have 6 slides, but I think I could probably still get them done in the minute that was given to me. So this, I think, is actually probably a very important thing for people to think about when you think about a software-defined data center. People sometimes just kind of start thinking about the bottom left. We all understand actually it talks about legacy mainframe, but then some people end up talking about new proprietaries. And so you can figure out who we are talking about, right? They kind of come and talk about all the stuff. Or you kind of what I call as Lego blocks. People just throw Lego blocks at you and say, here are all the white box systems, and here's kind of the thing's going to go do it. That's the one on the bottom right. The key is to find the right optimal combination between the white blocks, Lego, have at it, do whatever you want to do from a software-defined data center, or the top one, which is new proprietaries. So Dell, I think one of the big things that we have done actually as a company is to really kind of drive that software-defined data center. In fact, sometimes we call it software-defined infrastructure for not just one data center, but across data centers. That's kind of how we look at it. And how do we do it? We call it the lasagna approach or the hot dog approach. The left one being the hot dog approach, vertical smokestacks. And as we all know, modular data centers or modular infrastructures are always about kind of doing the right thing at the right place. So we call it, let's just kind of think about it as lasagna, layer them the way you really need to layer them, right? And Bob, I think, did an excellent job of actually talking about what we tend to call as do the right thing from a hardware acceleration perspective. Bob talked about things like how do you do OpenCL, and so it kind of takes care of the hardware acceleration portion, which is happening at the bottom layer right there, right? And in fact, we actually have one of our folks, Arpit, actually on Thursday to talk about what we call as application-centric, software-defined, hardware accelerator. So think about it from that perspective. The top layer is application-centric. So you want to have a software-defined data center that is application-defined. Application-centric because that's all it cares. Everything else is all serving the needs of that application. So you want it to be application-centric. Then you want it to be software-defined, as in software, the whole data center should be software-defined. And last but not the least, you want hardware accelerated where it makes sense, like what Bob talked about, all the details, right? So I'm not going to go through them. So if you think about those as 3 very different pillars that you're going to think about, and Arpit will talk about in his keynote on Thursday, that pretty much is the 3 different things that we're talking about here, right? And here's actually how to look at that stack. And Arpit will kind of cover a couple of things there. But the thing to point out here is, think about how it's being tiered, right? The bottom portion is the hardware accelerated portion, if you want to think about it. But everything should be a Lego block that actually is being put together. And one of the things that I always tend to use when I talk to people is to kind of point out that The biggest and the squeakiest wheel that we have in the whole software-defined data center is a thing called networking. I've been in the industry for a while. There's one analogy actually that people actually told me, which sticks to me even still right now. Obviously, I just bought a new house, and actually I go to Home Depot a lot. The one thing I always buy is super glue. How many of you know super glue was invented by NASA for sticking things in space? How many people knew this? I see some hands. That probably explains to me why super glue can kind of glue anything and everything. It doesn't matter. Metal, wood, glass, maybe not glass that much, but close enough, right? And networking is not that. If networking was a super glue, then guess what? We'd have probably had to problem solve. Every third letter actually utter, and every third sentence I say is probably 3-letter acronym. So you need to have a software defined. The only way you can do that is to make networking like super glue. And that's what, from a Dell perspective, we think about a virtual fabric, or active fabric as we call it. That's kind of how we do it. So it doesn't matter what you use. You want a super glue capability in the middle layer, and also a super glue capability in the bottom one. That kind of gives you that ability to kind of get the networking guys to stop talking about 3-letter acronyms and to really give you super glue and let the focus be on application centric, right at the top. And let the network and the whole infrastructure be software defined and hardware accelerated. And that is actually how we actually create that ability to do super glue. Here's some different kind of technology. If you go talk to Cisco, they'll come and tell you it is the bottom left because of the acquisitions they did. Go talk to somebody else like HP, they'll give you the bottom right and say that's the way to do it. I have 19 platforms, that's open flow. Or you go talk to people like VMware and whatnot, they'll talk about the top one. It is not about any of those things. It is a place that is there for each one of those things. And you want to make sure you have a super glue that can glue in the middle, that can put all of them together. Dell calls it open networking. It doesn't matter what different people call it. Ask for the super glue, right? And this is how Dell does a super glue. Very simple. Exactly actually what we have done actually in the server world, bring the exact same thing into networking. That way you disaggregate, move things around, and you can bring the innovation right into the place. And that's about Dell, and that's it.
Thank you.
That's a little more than 3 minutes, but close enough. And whoever is interested, I'd be glad to share with you the slides, because I don't think the slides are on the thing. So give me a card or something, or give me a USB stick.
One thing I've just learned is I'm not coming to your house. Because it seems like everything is stuck together with super glue. At least in my house, it's 1,000,000 use of duct tape. That's what I buy at Home Depot. I don't know about the rest of you guys. And the other thing, what's with lasagna? You're making me really hungry. I don't get to go down there and eat food.
Neither do I.
Well, that's true too. All right. So, apart from Bob and Balaji, we have here Paul, who is the Chief Storage Architect of Clouds from IBM, and next to him is Sri Panindra, is that correct? Who is the Director of Data Centers from Avaya, and at the very end is Robert Novak from Nexenta. Now, I would like to ask this of you first, Paul, since you're from IBM. All this SDDC, software-defined data centers, I have this question. If we're trying to put all this stuff together, hardware, software, data center, management, storage, servers, networking, how is this different to a mainframe? And why wouldn't we just go out and buy a Z?
Well, we still run a lot of Z.
Well, I know that, but why wouldn't we just go about doing that instead?
Well, it's all about your workload.
Okay.
And where does your workload, what does it need? What kind of capacity, what kind of performance, what kind of availability, and what kind of system was it authored to be on? I mean, I work in the cloud, so my key job is making sure we can provision storage, compute, networking on demand through a software interface without anybody touching the hardware. And then we can grow it as we need to. And so, you know, Z is a platform. We have P as a platform. We have X, which is the x86, as a platform. So we offer all the platforms in our clouds, and you can come and provision what you need. And the key goal is to be able to run that transparently, so you don't have to worry about placement algorithms, all those items. So Z is a wonderful platform. It's made IBM a lot of money. We continue to build it, but we also have a lot of other platforms to put your workload where you need it, when you need it, and how you need it. And that's the key message.
Thank you. Now, I'm going to go all the way down to the other side. Robert, you guys from Accenture and Dell are good friends, obviously. That's why you're sitting next to each other and you haven't killed each other yet.
Very cozy.
Yeah, a little too cozy from my end. The Accenture came, and tell me if I'm wrong with this, the Accenture came predominantly from a storage angle into the software-defined data center. Am I?
That's correct.
Okay, so is the software-defined data center focused around the allocation of data and storage? Would you say that? Is that the wrong way of looking at things?
Well, that was true in ancient history called logical block. And we're working very hard to get rid of blocks.
Okay.
It's a 125-year-old technology. It's based on, well, if you pick up any book on file systems, the very first thing they talk about is the unit record device. The old Hollerith card, which was first used in the 1890 census to tabulate the census data. So we have actually been using, in all of our storage technology that's 125 years old. It's about time to flush it down the toilet.
You don't look that old, by the way.
Close. Anyway, so the big thing that's changing is key value defined storage. So you've seen key value defined drives, NoSQL type databases that redefine that, so that you have introduced a new form of delayed binding. You don't bind data to a specific location. You find it by asking for the key to retrieve the value. And this makes the data much more flexible and changes the way you think about hardware completely, so that a whole bunch of ramifications fall through from that, including things like Ethernet attached storage instead of direct attached storage, and the CPU to storage ratio, and sensors everywhere to tell you who's got what where.
Okay, so I'm going to go to you, Sri. Robert mentioned about Ethernet, mentioned about communications. Why is obviously in that space? How critical is the networking element here?
So the network is an underpinning for any data center. So without a network, you can't create a computer from the computer, the server, the storage. They all depend on the network. So one of the pieces that Avaya is actually trying to look at right now, thought leadership is a fundamental use case of, okay, can I take any box that is about to be refreshed and replace it with a cheaper box and still maintain the sanity of my whole data center? That's what it's all about, the software-defined data center. I should be able to go ahead and replace something out there and still, it will be something that is a little bit more, it will be cheaper for whatever reason, and still maintain the sanity of everything and everything is working. So that's what we're trying to actually look at right now. And we have some technologies that will help that from a networking perspective.
Now I'm going to pit IBM and Dell against each other for a second. IBM has a fairly full stack from its own stables, and Dell has taken a partnering approach. Now, obviously, there are two different approaches to achieving the same thing. Software-defined data centers is all about flexibility, right? So, give us a little battle here. Why is one better than the other? And as users are sitting out here, how should they go about thinking about approaching software-defined data centers in that way?
Okay, now that I talked about lasagna and super glue, let me talk about my son who can answer that question there. Lego blocks is actually where I start, right?
Oh, I like that.
Okay, I think when you think about software-defined data center, you can talk about the mainframe on one end, which is I call the hot dog, which you saw there. Or
A hot dog?
That's what it was, the
I'm
hot dog
sorry.
mainframes, right? All vertical stacks, right? So, I know, I'm hungry, I gotta get that. The key thing to point, I think, when I talk about Lego blocks, well, the key thing to talk about is, I think, Bob also touched on it from his other series, not just Z, but also X series, right, from X86. It's about having the right Lego blocks, but not just talk about Lego blocks, but to have subsystems that can be put together and you can have instant gratification. When I give it to my son, I want to give him actually ability to put the Lego blocks together, but I want to put a plane together, call it a wing, tail, body. I want to put it together and then say, here is it, go have at it for your birthday so you can have instant gratification. Dell is all about that, right? Having said that, you can actually replace the wing, you can replace the tail, you can replace the body, or for that matter, you can customize each one of those things. It is that ability in the middle of being able to do the layered approach and be able to mix and match, which is where Dell comes from an open perspective. That kind of gives you the flexibility and do that without having to actually go and change and still be able to provide an application-centric focus that I talked about before. And that ability to do that, that software defined and changes Lego blocks, that's where Dell comes from. When we talk about open, that's what we mean by open. That's why Dell takes a partner approach and we bring in different folks, like Sandra being one of them for storage. We actually have our own storage implementations. And at the same time, in fact, one of the biggest questions that we asked is, okay, can I replace a Dell server and put somebody else's server? Absolutely. You don't like it? Yeah, sure, we can. Can I replace actually a Dell networking and put somebody else's networking? Yes, we can. You don't like it, but you can. If somebody can make that statement, then it is truly software defined, and again, without impacting application-centric focus.
But Balaji, hang on a second, before IBM answers. When I go out and buy my Lego blocks, the really intricate ones with the programmable stuff, for me, not for my son, I read the book, and I follow the book, and it's all Lego branded. So that's not proving your point here. I'm still buying all Lego stuff. I'm downloading Lego software to plug into the Lego USB port.
Very, very good question. Think about different colors of the Lego actually coming from different vendors. That is the answer.
Okay.
And the book that you saw was really the reference architecture for the solution, how it needs to be put together.
Okay,
That's the book you're reading.
Okay, thank you.
Yeah, so from IBM, we definitely have, we're a large company, we have multiple business units. So we definitely have the ARM supplier units, you know, the processors, the compute nodes, the storage equipment. But we also have a very large portion of the business, which is an integration service business, where we take lots of different parts, and a lot of times they're purpose-built. I mean, the customer comes to us, and they will have multi-vendor components. So we will take those components and hook them together. In our cloud, we are IBM. We try to use our parts first where it makes sense. If we don't have a part, we go out and we get another part to build our solution on top of. So it's more of a solution integration opportunity that we see from the software-defined data center and cloud perspective. And we take advantage and we leverage where it makes sense the ARM supplier portion of IBM, you know, the storage team, the server team, most of our SAN networking is OEM gear, so we don't produce it all ourselves. We do partner with others. So that leads to, you know, standard interfaces, standard interconnects, standard layering as much as possible. Unfortunately, not everybody has the same interfaces. You know, how to run a Brocade SAN versus a Cisco SAN is different, and so we support both of those. And so I don't think it's, you know, a whole blue environment. We do work to provide the proper integrated solution for those workloads to our accounts.
All right. I'm going to ask Bob to answer a question. We're going to give you a little bit more time here, Bob. I know you did. But for, we teased you a little bit about the length of your presentation. There's a good reason, because there are a lot of intricacies about how to interconnect the various parts within a software-defined data center. Give us sort of a very brief overview of the importance of those interconnects and how that interconnects are A, important, like I said, but B, how that affects the performance and ultimately the efficiency and effectiveness of the software-defined data center.
So I'll be short.
Very brief.
So basically, I mean, if you just look at the two answers here, is if you first off, I don't know of a full software-defined data center working today. I hear there's a couple, but honestly, if you start looking at all the different APIs of piecing these things together, it creates a tremendous amount of problems, and so the integration takes an enormous period of time. Adding in all the different APIs of a Cisco box into the system and works with the Broadcom top of racks designs or switches creates a lot of problems where the software guys actually have to go back and write either new APIs or they have to merge these capabilities together. So just from a networking perspective, it's a huge amount of overhead for the integration side of things. So it's not unusual to buy a piece of hardware and integrated 6 to 8 months later, which is a fair amount of time. As far as performance is concerned, it's really a matter of how efficient those APIs and your software stack is, and that's pretty much what's going on right now. So once we get into a standard set of APIs, like you do with an open flow environment, is at least you have a base building block.
So, Robert, we just heard about openness. How do we achieve that in all these building blocks? Because there are a lot of suppliers in this space.
It requires standards. Standards around APIs are the most important part of the entire equation for putting your open data center together that is truly software defined. You have to stay away from your proprietary lock-ins at every level. And you have to keep being very strict about not falling into the trap of, oh, but it's so much faster if you use this. You have to stay with the standard API that keeps you at an abstraction level similar to virtualization that keeps you away from those proprietary
Hang on. Okay, there's what you say, and let's look into the reality, right? Everybody here is going to tell me, we are here to open standards, but we're better,
Yes.
right? So, what's the reality?
The reality is, as soon as you fall into that extension trap that gives you something a little bit better, you have a short-term advantage and a long-term lock-in. And that short-term advantage is not worth getting that long-term lock-in. Because this is nothing against any one company. It's technology evolves at a changing pace. Sometimes A's ahead, sometimes B's ahead, it doesn't matter. You, as the customer, need to keep yourself flexible so that you can move and shift to those technology changes as quickly as possible when they become available.
Okay, I'm not trying to pick on you specifically, but you're the only software vendor on this panel, okay? So I'm going to pick on you. You're saying all this, so if we're going to come to the common denominator, how and why would you be any different or better or than anybody else? Or how can any software be
As a software
better?
company,
Or as an API provider and an infrastructure software management instrument, insert your own noun here, provider.
well, one of our biggest challenges as a software company is ensuring that our software runs on variations A, B, C, D, E of hardware. In fact, that's probably our largest single expense, is doing all that verification so that we can present a level playing field for all the layers above. But all the vagaries of little details in storage devices, things where thermal ranges are redefined on a disk drive that causes all prior definitions of those drives to suddenly stop working, and you can't get the old micro firmware for the old style support. Those kinds of things cause incredible nightmares. And those are the things that we have to keep layering on top of to hide all of that idiosyncrasies from our end users. And that's what you have to work with from both this hardware and software standpoint to ensure that you're constantly getting that level playing field.
Okay, at this point I'm going to outsource my nitpicking to one of the members of the audience. Yes, sir. Can you speak loudly, please?
When I hear open stack, open anything, I'm thinking interfaces, APIs, even internal interfaces. My question is, why can't there be a difference in performance between two different implementations of an open standard? I don't see a dichotomy. I think we simply could have improvements.
That's a good question. So let me just make the answer this way, right? I was actually talking to the architect at Microsoft who actually architects Windows Server, Jeffrey, and he gave me a good example. I want to repeat it here. We all understand that Windows has gone through enough iterations, but the one good thing is plug and play. We all understand how good it does a good job of plug and play. And that's a good answer for your thing, right? The hardware abstraction layer that is done, I think that's a good example of it to say, no, when I bring up my server, and actually it has any video card, it doesn't matter, any drive, that doesn't matter. It is going to come up and it's going to perform at the basic level. Okay? To Rob's point before, if I put that software driver on top of it for NVIDIA driver, obviously it's going to actually start using SLI, all the graphics capability of the NVIDIA card, which is very different probably from the Intel graphics. So that extra capability is added on top of an existing standard infrastructure and the standard API. The key question is, and that's it, what you, because as Dell, I think we actually push this very hard, and we want to make sure, not just from a software as well, the service perspective, laptops, it doesn't matter on networking, doesn't matter storage, that API is very key for us, and everybody thou shalt conform to the standard API. If you want to extend it to the driver, that's a very different discussion. It's okay, that's the hardware accelerated portion of it. But you have to conform to the basic fundamental building block. If you don't, then that's not a Lego block. Inside the Lego block, you get something different. It's a different problem.
Hang on. Do you have an answer? There was a question over there. I'll continue my outsourcing that gentleman over there.
Oh, okay, but my question is totally different.
Why not? Go ahead.
Okay, good. Brian Zonstecker, Power Rocks. So, being a server power guy, power near and dear to my heart. So, since you have a nice mix of hardware and software folks, I'm wondering, you always talk about, you talk about how to improve efficiency kind of usually at the box level, maybe how that scales up to the data center level, PUE. But I'm wondering how SDN can take it to the world level. And so you have a lot of opportunity with all the folks in the software and the hardware for unique power management, digital power, aside from control, scheduling, telemetry. But also you have the flip side on the smart grid side, with all these renewable sources and this kind of two-way power of grid power. So I would imagine that there's a big opportunity for a software brain to optimize both those worlds and marry them for what would be optimal on a global scale. Simple question.
Somebody else want to take it?
Yeah, I can.
Yeah.
So the thing is, there are already a bunch of applications, the software applications that manage the power on both fronts, right? We're talking about the connected grid and all of those things. However, what you said is right. Those applications still haven't come into the world of your data center, right? I think you have a good point. There is a good opportunity out there to actually do something to introduce power management as a part of your open interfaces or a software-defined data center. I agree with you.
Actually, I would disagree with that panel, right? So that way we create some spiciness here.
Fight.
So, I know actually I heard from the IBM folks, actually the software-defined data center is not here. Please go back and actually look at Microsoft's announcement on Cloud Platform Server, powered by Dell. That's a software-defined data center announced by Microsoft, it's available for you to buy today. Please go and actually look at EvoRail, announced by VMware, powered by Dell. Yet another software-defined data center available today, you can go buy it. And if you don't believe any of those two things, actually go on the rooftop of eBay, actually PayPal to be specific. And you will see a modular data center powered by Dell in the roof of PayPal, running fresh air cooled. I repeat, fresh air cooled in the top of Arizona's rooftop, powered by Dell. These are software-defined data centers running today. And if you don't believe that, I can tell you actually 7 out of the 10 super web hyperscale environments is software-defined data center running today. Having said that, to answer your question actually about power grids and whatnot, the triangle slide that I put up there, that is actually your answer actually for software-defined data center across multiple locations. There is actually the top portion of that particular slide talks about overlay. That's exactly how you cross across multiple locations, and that is being done today. One of our customers actually is running 3,000 Dockers per second, and I repeat, 3,000 Dockers per second transformation is running on a software-defined data center today. And the one on the bottom left is actually used by one of our Web 2.0 search engine customer, and that's actually used using REST API today. The thing on the bottom right is actually used by a few of our customers today on hyperscale data centers and HPCs. It's here today. We just have to just go and work with the right folks to make it happen.
I agree with my friend here, Balaji, that we have vendor-defined data centers today, not software-defined data centers.
all using Lego blocks, but not Dell. It actually uses all, it uses competing products, exactly like what was pointed out. Yes.
I forgot to bring my adapter. I actually had satellites right on top of Arizona at the eBay Center, but I can see it right now, but I'm sorry, I'll show it to you later. On top of their roof. Oh, hang on a second, NASA's just breaking in, so we'll get back to the questioning right now. There was one more gentleman here with a question.
Yeah, I wanted to bring this back into the Lego block thing. And so, if you
Louder, please.
Use the mic.
Oh, yeah.
So if we bring this back to the whole Lego block thing, if you look back in the the 80s and the early 90s, when the whole idea of componentized software was starting to get really interesting, right? So you had two big divergent views. You had the whole, the castle on the hill, which was the whole small talk view, which you could translate into a unified, highly integrated, vertically integrated stack, which is maybe the IBM view of the world in some ways, right? Then you had another thing where right around the 90s, the early 90s, Microsoft came out with a software bus they called the component object model, which was all about componentization at very fine grains, very large grains, and it was the basis of almost all of their technologies for even until today, right? The problem was that in order to get the componentization that you need, right, you had to go to a model that was so different than what people were used to, right? That to get the interoperability and the performance and all the trade-offs you have to make Lego blocks really work, it was so different that the productivity was a real hit. So then along comes another castle like Java, right? Which didn't solve any of these componentization problems, but made productivity easier, right? And then all of a sudden that took mind share away from the whole Lego blocks thing. So the question I pose back to you guys, both views obviously have value. They're both important, but they both have to, maybe the next generation thing should be an open services type of thing, vertically integrated, because that's what we're missing.
Yeah, I think you brought up a very valid point, right? Which goes back, I think, to the point about open standards and layering them properly to open standards, and be kind of maniacal about open standards. Because, like, for example, we respond to many of our customers' requests by saying, you know what, you don't like it, but you know what, I'm conforming to the open standard, and thou shall replace and shall conform and use my competing product. Not a problem at all. We consistently do that. Like, by the way, 2 examples I gave of cloud platform system powered by Dell and EvoRay powered by Dell. By the way, notice in 6 or 8 months, you'll actually see the exact same thing also powered by other competition. And we are enabling them to start with. So we are the enabler to start this ability to happen. But the key thing is what we help working with these vendors is to create that standard layer. So while we actually help the build complete stack to be available, actually powered by and delivered by VMware and Microsoft, they're going to come up with the same thing with Supermicro. The same thing is going to be coming up with the Cisco implementation. Same thing is going to be coming up with actually HP. And the key thing what we're enabled to do for the industry is to create that standard. And the emphasis on the standard, like I think what Robert was talking before, is very key. This is why I was quoting Jeffrey who was one of the architects of Microsoft, that HAL layer that people talk about in the server, you got to take it to this data center.
So building a heterogeneous workload environment on a homogeneous environment isn't there today. There is no single Lego block that can do every workload under the sun. It doesn't exist. So you have to have different types of blocks, Lego blocks, wood blocks, towers, and you have to integrate those together to support your various workloads. I've actually been involved in building a number of appliances out of COTS components. It's pretty easy to get the first iteration running, but to make that thing run 7 by 24 by 365 with all the other pieces that never work together, this is hard work. And so you have to be able to carefully select your componentry and how you put it together to make sure it meets your requirements. But you can't just go pick a building block from any vendor and make it happen. It just doesn't work that way.
Thanks for your question. These guys will be here to obviously answer some more at the end. There are 2 more questions that I'm going to ask them. I think it's one. These are questions a little bit more futuristic, but nonetheless important to ask. And I'm going to address this next question to you, Paul. You're the chief storage architect for clouds. So as we think about software-defined data centers, my natural inclination is SDDC equals cloud in-house, and then cloud as we know it is cloud in the cloud. How do we choose between the two? Aren't they essentially the same? One I have to run, and then the other is one that somebody else has run.
Yeah, so we offer, if you want a private cloud that you run, we can give you that. If you want a private cloud that we run, your prem, our prem, we can give you that. We can give you part on your prem, part on our prem, so we can do that. It all comes down to also, I mean, storage and cloud. Claude talked earlier today, if you went to his presentation, you have different, storage service levels that you need to offer, storage classes. So you have to be able to offer the different types of capabilities that are there. Networking is very key to a hybrid environment, being able to have your compute next to your data, and then be able to tie those compute resources together with a high enough bandwidth, with low enough latency that is crucial. And don't forget multi-tenant security. That is like pretty damn hard to do.
Right. That's
And
probably
especially building off of component parts that never thought about multi-tenancy in their life. And so building multi-tenancy into that environment, even if it's a private deployment, you still have multiple departments that need security between them, so you need the multi-tenancy in there. And that brings a whole new level of control plane into the picture. And then you talk about, I heard other talks today, copy services between those. I mean, just giving somebody a storage volume is pretty easy. Making it resilient, getting it redundant across sites, all the integrity, and at scale brings multiple challenges. And we offer that today. We have two predominant platforms. We have the software team we bought last year, and we have our enterprise cloud. It used to be called PC Plus, now it's called Cloud Managed Services to manage that for you.
Nothing to that? Oh, okay. You got one?
I just have one thing I want to talk about in terms of the software buses that were mentioned a few minutes ago. We are actually in the golden age of software componentization. A long time ago, when I was doing hardware design while I was in college, we had the TI 7400 series Bible that you could pick semiconductor chips literally off the pages of the catalog and put them together, Lego block-like, to build a circuit. Today we have the same thing existing with software components. But what we don't have is the huge FPGAs of software. We have legacy monolithic applications, but we don't have ways to do those building block buses that were talked about earlier. Those buses are still in their infancy and have a long ways to go. Don't fall into the trap of getting caught on a software bus too early. Stay with the components that have standard APIs, and you have to design your own mix and match to suit your needs, your purposes, not necessarily your vendor's purposes.
Okay.
I want to add a little bit more to that.
Okay, sure. Go ahead.
Yeah. Actually, I think I like that point. It's not, to answer one of the questions that was asked before about, because things like talk about Java and whatnot, but in reality, if you go to financial services and some of the implementations of applications, notice I talked about application-centric. Think about some of those high-flying things that are running today, NASDAQ, all those stuff. It is message bus is the key, right? It's not about Java. It's about, is it a rendezvous message bus? Is it the IBM MQ series? Is it, what is it running, right? That's what is key. That layer is so key. Then you can start adding and pairing. So it's all about the standardization of the right place, the right time. Then you can mix and match. And that's the key thing. And talking about actually in-house versus outsourcing, I think the key thing is all about, I think, super glue. There's nothing called super glue. That's what makes this darn thing very hard. And somebody else was putting, Paul mentioned, networking is kind of like the Achilles heel. It kind of creates so much of trouble. So do not take it lightly. Think about what is going to give you the flexibility you want to layer things properly. And networking is one place where you think really hard. You're going to have a religious thing about going to a vendor. You're going to be stuck for a very long time.
What happened to your 3-minute? What happened to your 3-minute promise? Number one.
Sorry?
What happened to your 3-minute promise? You would stop talking after 3 minutes.
That was for my presentation.
And by the way, I'm going to send you a gift. I'm going to send you the book called 1001 Uses for Duct Tape. All right, guys, just to finish up here, I'm going to ask a question to these guys, which is much more fun than what we talked about. Okay, we talked about software, essentially within the software-defined data center, what does it encompass? Software-defined networking, software-defined servers, software-defined storage, right?
And security.
Sorry, software-defined security, software-defined this, software-defined that. Okay, when are we going to have the software-defined storage server or software-defined administrator? Come on, this is a real question. When do we get to that point that we have the software-defined administrators?
3014.
I think we should ask Facebook.
Boss, Facebook? Okay. What does it take to get us there? I mean, I know I'm asking the question somewhat in jest, but there is a serious aspect to this.
So
Where
much
do we get-
capacity everywhere
I'm
that
sorry?
there's more capacity than anybody can eat on any of those
Mhm.
3 legs that you don't have to worry about.
But we
You
kind of
just-
have that now.
No, you don't.
Okay.
Yeah, actually, as I said, that's an excellent question, right? Software-defined administrator is defined by actually ability to actually be able to do I'm going to switch this gears from enterprise IT to carrier infrastructure, NFV, right? Today, software-defined administrator is done by actually not doing a truck roll, by not doing actually ability to having to say, you know what, oh, you want to provision this print service? Guess what? I really need you to go home and come back 3 days later. Being able to have the service instantaneous, which is what we can get on any of the carriers today. And when those carriers can now create those new services on the fly, which they cannot do today, which is what NFV delivers. That's the starting actually of a software-defined administrator. Because me as an end consumer, if I can put together services on my own, the carrier is not doing it. Now it is software-defined because it is end-user defined. Candidly, like Paul talked about in terms of actually hybrid-based implementations and whatnot, if multi-tenancy, if me as a consumer of the multi-tenant cloud, if I can put together, and actually I can spin up VMs, and I can spin up stuff like what you do in AWS, that is software-defined administrator because AWS is not doing it. It is done by me as a consumer.
I think when you get to self-configuration and all the other stuff, you've outsourced all your server needs onto the cloud and let them take care of it. So when you look at it, ultimately is, I think everybody talked about it, is ultimately is the APIs have to be standardized, software has to be standardized, and then you have to have 30,000 engineers writing software that is robust enough, right? So ultimately is you either buy a system from Paul here, or I know you know that. And so, you know, I think we have a long ways to go. I think the beginnings of it between NFV and software-defined networking is going to help things out a lot. But a complete self-configuration with nobody having APIs is kind of like buying a $10 Cisco switch. It's not going to happen.
Ladies and gentlemen, I want you to help me thank Robert Novak from Accenture, Balaji Vichai from Dell, Sri Fanindra from Avaya, Paul Bradshaw from IBM, that was much easier than the rest, Bob Pierce from Altera, and I am going to become a software-defined moderator. My name is Ben Wood. Thank you very much. Have a great time.
At least didn't fall apart.